Alright, explaining all of terrain because this is the last bit of the engine aspect to show, and then past that I'll show sprite font since I was working with a bunch of others on getting that last bit in just to squeeze a little bit for the project since I'm a big dumb idiot. Anyway, so here's a terrain cell. Terrain cell essentially keeps its min-max point, a color, and then the four vertices that compose it, or at least on the x and z axis, to be used later to compute the normals. The very bottom level tier class is the terrain cell model. It's worked out as a it's here. Words. Anyway, so this creates this terrain cell model based off the height map. You define the length, max, height, y transitions, and then the size of the UVs. This is find cell. Shithead itself is meant to be used for a game object's position or any vector for that case to find that specific cell per vector. This is the texel index and the cell index. Here's a terrain render, which is very specific to itself in that I use a null object to skip the whole drawable sequence to make sure things are switched out properly in between scenes. Here are getter functions for the min-row and columns and max columns. And this find that fuck square is pretty much what most people would say is computing the rectangle based off of the B-sphere or the ABB created for the B-sphere in your iterator, which I will get to in a second. And then Berry Boy is finding the barycentric coordinate on the plane itself. And then there's a shit ton of legacy code because it was a field day for me and my boys when we were trying to figure out all this shit. Compute cell from shit is computing it specifically from the INJ or the row and column that you give it. Here's a bunch of stuff. Constant color, compute cell data, specifically fills out each terrain cell data based off of where you are. And now going inside the model itself, here's the construction. So essentially it's ripping out what we did in graphics and extrapolating upon that. I realized the graphics way I did it was wrong. So to fix that, essentially I was always maximizing the sides to always be 256, but realistically the sides are determined by the image width and not the magic number of 256. Or is it 255? Either way, it's not that number, it's actually the image width. And then from there, this is the first loop, or first nested for loop to essentially set up all of the vertices correctly. And then this anchor boy is essentially my anchor point for the 0, position on my terrain. And then within here, this is where it gets kind of funky and weird. So first and foremost, we're essentially saving all the vertices that create the triangles and setting them up as such. This is the top one, this is the bottom one. It should be counterclockwise. And then here is my nasty ass check for normals, or when exactly to do normals. So it's basically skipping any row or column that is 0 and skipping any row or column that is side -1. It's side minus. It's basically keeping within the inner square, skipping row 0 and row side, and column 0 and col side. And from there, it grabs the 6 verts in that weird diamond pattern. So the up, left, right, down, and then bottom, left, and top, right. It sets them within their actual points, and then from there, it creates the vectors from subtracting those points from the midpoint, and then a bunch of cross products to get the essentially the normals of it all. And I messed up, but I don't have time to fix that. Since my winding is slightly off, like in hindsight, my quick fix to this after getting the sum and dividing by 6 was multiplying by -1 since all my normals were pointing inwards, because I am a smart cookie. And then it's just saving those normals, even though realistically, in hindsight, this is redundant since the p-verts are destroyed, but it's all saved within the normal array. And if it's the edge cases past these, it goes into just saving the normal vector itself of up into the array around the ring of the terrain. And then from there, it does compute cell data for pretty much each cell gets the p-verts for the top, left, right, and bottom, and then it gets the actual indices for it, and then it iterates over. From there, it's just standard model creation. So create your model and your graphic object model. In my case, I have two. One's a graphic texture light and one's a wireframe, so you can actually see the proper squares of all of the not squares. Well, yeah, I guess of all of each cell, and it sets them both, and then properly cleans up and deletes. Terrain model properly deletes everything it creates. This is legacy code, don't mind that. Here's a Texel math. Since this is OpenGL and I have no control over how the graphics part works, I skip the alpha channel. So it's only taking the first three cell indexes specifically. The cell index basically multiplying only by 1 or 0, not 0, just 1. Here's compute cell from shit, which is grabbing the cell from a row and column. Here's some simple clamping math. In hindsight, I could have probably put this in its own function and have a bunch of integer references to it to do it correctly. The render basically calls render on both the wireframe and the actual graphic object. Compute cell data goes through pretty much everything and sets up the cell min point, max points, but specifically only on the Y does it do the calculations. For the X and Z, it just grabs them and sets them to it. Don't mind this offset. This offset was used before when I was testing setting the terrain in the center. I gave up on that only because I was running out of time. There's the 4 vertices, and then this find cell I was going to delete, but it turns out I use it specifically for very centric. Again, with the clamping, I could have fixed that better. Here's the magical find that fuck square, which essentially grabs a collidable and then sets these min and maxes that are passed in. The collidable gives its B-sphere, which essentially gives the ABB volume, and does as such to set them correctly. Here is when I had too much power, but I literally removed it all because you said to. So variable used to be an interesting looking function, but now it no longer is. Past that, Berryboy basically has a vector for bboy, grabs the cell index and sets it to grabs that current cell. And from that current cell, you could extract all the not vertices, but the indices of those verts and just straight up grab the normal, so we could skip a few steps. And then from there, we have vector new pis, which is essentially new position for everything, based off of that. Or it's a new position based off the barycentric, and it's divided by the length to get the proper sizing. And then here's a very simple micro clamp, essentially. This is to help out if I run off the edge, it doesn't freak out. It sets it either to 0 or side -1 position. And then here we chop off the ends so that it's just the solid I and j essentially of that square, and then subtracting that from the actual positions gives a percentage within that cell. And then from there, we do a check if x is greater than z, which helps determine whether or not you're in the top and bottom. If we're in the top, then we do this magical barycentric bullshit. Yeah, if you open up all the notes on this, it'll be an interesting time. That's all I can say there. It returns that, and then the rest that's hidden is legacy. Now, the actual terrain object itself, it essentially just has a bunch of accessors into the terrain, which are actually a lot of them are shut down now that I think about it. But yeah, so it has find cell, terrain fucker is a pointer for terrain model, just creates it based off of that. It has its own personal draw and a terrain object destructor, which checks if the model itself is is there, and if it is, then you destroy it. Otherwise, don't worry. Here is my terrain null object, which literally just has a draw to override, pretty much just so when you switch scenes and it constantly checks, it doesn't freak out. What I mean by that is in my manager, one second, no, it was not manager, my bad, I'm fairly sure it's within the scene itself. In the scene itself, I constantly call the terrain manager's draw, which is always calling something, so that's why there's a null object. It's a lot cleaner than making a scene level manager to handle all this junk. But yeah, so that's there. For the iterator itself, let's go through. So here's the terrain rectangle area, but I call it thing because it's me. What do you expect? Specifically, it calls find that fuck square, which grabs the iteration volume essentially, and this is the beginning and end of the iterator itself, meaning the terrain iterator's start is always at the min ing and the end is always the max ing. As for the iterator itself, here it is. There's the current i's. Here's overloaded plus plus operators and overloaded boolean equals and not equals operators, and then a get cell specifically for that. So within this basically calls compute cell from shit, which grabs your very first cell within the whole thing, since the very beginning should always be the minimum ing, and then the operator plus plus essentially cycles through. Ooh. Yeah, so basically it cycles through, and once it hits the end of a row, it resets the row to 0 and then increments the column. I might have just said that backwards, but you get the idea. It's there. Operator equals is this. Not equals, this is just overloading, not overloading, but defining the operator equals function. Here's the equals, it both have to pass for to return true. And then this here is a son of a bitch in itself, because negating or doing not equals and not equals always was a very finicky motherfucker. Only because it only showed part of the square, specifically because it would stop at the iterator for or the plus plus sequence for the current I, since that's what gets cycled through. And that is all the iterator. I've shown you the terrain command before, but I will show you it again. If you don't want to learn more about the terrain command, then just skip ahead. But if you are sticking around, as I've said before, go to depth. Essentially, you grab the area you're going to use and then create the iterator based off of it. Begin cell sets you the minimum, and then the end cell is the maximum ing, and from there you're just going through that small volume instead of the whole terrain. Let's see. I've already gone over collision with terrain, the whole thing itself. So I guess I could just show you how things work real quick. Alright, so just showing you real quick. Hitting I goes into my GuideCam mode. The more I think about it, the more I realize, since this is an OOBB, you'll barely see the actual collision happening, so to speak. Except for maybe if I drive up this hill. Oh yeah, I have the skybox connected to the actual. Does it collide? I don't think it actually collides. Oh yeah, okay, so in that slight second you can see there that it's colliding properly. And that's literally because the actual collision volume itself is what do you call it? Since it's an OBB, it's extremely precise. Yeah, next video that I'm going to show you is going to be pretty much just the project work and then everything within the game.